Okay, so let's look at this question where we assume that the probability of a customer leaving their cell phone company can be modeled by an exponential probability density function. Given here, f of x is equal to 0.2 e to the negative 0.2x, where x is greater than or equal to 0, and 0 if x is smaller than 0. So this is a probability density function, f of x, and so what we're interested in is what is the probability of the customer leaving in the first 2 years, what is the probability that the customer leaves after 5 years. So this is a continuous random variable, and so we use probability density functions to calculate these things. So let's get started. For question A, we're interested in what is the probability that this random variable, namely when the customer is going to leave the company, leaves in the first 2 years. So x is between 0 and 2. And because this is a continuous probability density function, to calculate that, what I do is I integrate between my two endpoints, 0 and 2. And the function that I integrate is the probability density function. Now, if I look up here, anytime that x is greater than 0, which it certainly is if x is between 0 and 2, anytime that x is greater than or equal to 0, the function I should be using is 0.2 e to the negative 0.2x. So this becomes the integral from 0 to 2 of 0.2 e to the negative 0.2x dx. We can take that 0.2 out if we would like. It becomes 0 to 2 e to the negative 0.2x dx. And now I just carry out this antidifferentiation. I get 0.2. The antiderivative of this is 1 over 0.2 with a negative in front, e to the negative 0.2x, and I need to evaluate this between my endpoints, which are 0 and 2. So if I go ahead and do that, what I will get is 0.2 times, let's plug in the 2, and we get negative 1 over 0.2 e to the negative 0.4, because I've multiplied 0.2 times 2, minus what I would get if I plugged in 0. Now, there's this minus here, and that'll cancel with this minus and give me a plus. So this becomes 1 over 0.2 e to the negative 0 times 0.2 is just 0. So this ends up being 0.2 times e to the negative 0 is 1. So this becomes 1 over 0.2 minus 1 over 0.2 e to the negative 0.4. And if we actually work that out, that's approximately equal to 0.33. So the probability of the customer leaving in the first 2 years is approximately 0.33. Okay, so part B says, what is the probability that the customer leaves after 5 years? This is kind of strange because we don't have really endpoints here. We're saying, well, anytime after 5 years. So what that is that's the probability of our random variable taking on a value that is bigger than or equal to 5. So we certainly know that this should be the integral of 5, starting at 5. But what should the integral end at? Well, because we don't really care about what the value will be as long as it's bigger than 5, we should use an endpoint, quote unquote, of infinity. So we are interested in what is the probability that x takes on any value from 5 until infinity. And so we would like to carry out this integration of the probability density function. So using improper integrals, this is the limit as capital N goes to infinity of the integral from 5 to n of our probability density function, which is 0.2 e to the negative 0.2x dx, which is equal to, the 0.2 can come all the way outside, limit as n goes to infinity of negative 1 over 0.2 e to the negative 0.2x at 0.2, limit as n goes to infinity of, same kind of idea of what we just did up here. I'm going to plug in, I should put in my endpoints here, 5 to n, so I'm going to put in my n, negative 1 over 0.2 e to the negative 0.2n, and I'm going to subtract off what I get if I plug in 5. If I plug in 5, I subtract off what I get when I plug in 5. This negative cancels out with this negative, so I get a positive 1 over 0.2 e to the negative 5 times 0.2 is 1. Okay, and if I let n go to infinity, well, the only place that you see n in this line here is in the exponent here. As n gets really, really big, this becomes a really, really huge number in the exponent, but a really, really huge negative number. So this, as n goes to infinity, is going to go to 0. So that means that at the end of the day, our probability is 0.2 times 1 over 0.2 e to the negative 1, and that works out to be approximately equal to 0.37. So the probability of the customer leaving any time after 5 years is approximately 0.37.